Good day, I am Mr. Javen Tuburan, Master in Technology Management, and I'm going to present my research about Microcontroller-Based Electronic Components Learning Kit. For the introduction of my study, hands-on learning. In today's modern education, hands-on learning is a more engaging way to learn. Hands-on learning increases retention and offers practice in critical thinking. One example of the tools used to stimulate learning is a manipulative. Manipulatives are physical tools of teaching that engages students visually and physically. The Department of Education greatly encourages the use of the hands-on on learning to achieve its aim. The K-12 program of the DepEd aims to prepare students for employment, entrepreneurship, higher education, and middle skills training after high school. The Technical and Vocational and Livelihood Education Program of the DepEd offers tracks that give students a chance to learn work skills in cookery, welding, electronics, ICT, dressmaking, and among many others. Specifically, for electronic students, needs to have an in-depth knowledge of circuit and electronic components. Therefore, a learning kit will help the students in understanding electronic components in a more engaging and technology-driven way. For the general objectives of the study, to design and construct a microcontroller-based electronic components learning kit. Specific objectives of the study, for the number one, design and construct a microcontroller-based electronic components learning kit with the following technical features: easy setup, accurate reading of components, user-friendly, long battery life. Number two, test the functionality of the microcontroller-based electronic components learning kit in terms of setup time, accuracy, of reading, battery discharge time. And number three, evaluate the acceptability of the microcontroller-based electronic components learning kit as to its design, durability, ease of use, and safety. And number four, formulate a user manual of the microcontroller-based electronic components learning kit. And the last, number five, create activity sheets for the microcontroller-based electronic components learning kit aligned with K-12 competencies. For the instrumentation, in terms of its accuracy, in measuring components readings, it will be compared to a standard multi-tester and evaluate each device's performance. And in terms of battery life, the battery meter will be checked in 5 times interval, both in standby and active mode, to measure the rate of battery discharge. In terms of acceptability, the researcher came up with a questionnaire that will evaluate the design, durability, ease of use, and safety of the learning kit. So this is the example of screenshot of questionnaire being used. For the validity of the research instrument, the researcher made questionnaire was validated by 3 experts from the field of electronics and 2 experts from field of education. The validity test resulted to a score of 4.92. For the reliability of the research instrument, the instrument was subjected to a dry run among 15 electronic product assembly servicing or EPAS in situ students from Barangay A. Lopez National High School, Silay City. For the respondents of the study are 15 electronic products assembly and servicing EPAS students from the Senior High School Department of Doña Monserrat Lopez Memorial High School. This is the design plan, preparation, and fabrication. Workflow, preparation of materials, tools, and equipment, laying out and cutting of materials, fabrication of the learning kit, assembly of parts of the learning kit, finishing processes of the learning kit, test and evaluation of the learning kit. Discussion of the result. For the setup time, the table shows the amount of time spent to unlock the kit, turn on multifunction tester, and insert the alligator test proof into the socket. The data shows that after 5 tests, the average time to set the learning kit up is only 26 seconds. The user can then start using the kit to test the electronic components inside the kit and answer the activity sheets. The table shows microcontroller-based electronic components learning kit, both in its closed and already set up mode. When not in use, it should remain closed to avoid entry of dust, moistures, and moistures. For the accuracy test, the table show 5 attempts were made in comparing the measurements using the microcontroller-based electronic components learning kit and a digital multimeter. 2 resistor, 3 capacitor with different types were used to determine whether or not the two devices measures the components with the same value. The results show that there is very slight differences in the measurement from the two devices, taking into consideration the percentage of tolerance of the components. The table shows that the learning kit accurate in reading all types of electronic components. Even when using the standard multitester and the pen test probes, it shows the same reading of the components' electronic values. For the battery life test, the table shows results the testing the rate of battery discharge both standby and active. On standby mode, 5 attempts with an interval of 5 hours were made to check the battery life. Data shows that the battery discharge only 0.01% for every 10 hours. On active mode, battery discharge is on average of 0.36% per hour of continuous use. For the acceptability of design, the table presents the overall impression of the respondents toward the design of microcontroller-based electronic components learning kit. Shown on table were results that give an average of 4.97, mean and interpreted as highly acceptable, with a 0.09 standard deviation. For the acceptability of durability, the table shows that the administered test for durability of the microcontroller-based electronic components learning kit yields an overall mean of 4.92, which is described as a highly acceptable with a standard deviation of 0.12. The result implies that even the continuous use of the tester and the components in answering the given task, the respondents readily recognize the durability of the actual casing of the kit, its a battery life, the accuracy of the tester, and the durability of the components. For the acceptability of ease of use, the table shows the innovative manipulative garnered the overall mean of 5 and is interpreted as a highly acceptable with 0 standard deviation. This category is acceptability received a perfect score from all the respondents of the study. This implies that the respondent evaluated the learning kit as a perfectly portable, can measure different electronic components with different sizes and values, and can identify the necessary identification and measurement faster and easier than the other devices. These results also prove that the learning kit allows first-hand experience of the basic principles of the electronic components. For the acceptability of safety, the table reveals that the safety of the learning kit was secured, of which it's garnered the overall mean of 4.9 or 4.90 and interpreted as highly acceptable with standard deviation of 0.16. These results imply that the microcontroller-based electronic components learning kit was fabricated with the objective of not causing any physical harm to its users. Leakages poisoning from the battery are very unlikely to happen. The power source used was commercially brand that has its own protection from such occurrences. And for the user manual, the 4 objectives of the study is the development of the user manual for the microcontroller-based electronic components learning kit. This was developed with the utmost goal of guiding the user of the specification, proper usage, correct reading of electronic components, maintenance, and to ensure safety. And for the activity sheets provided in the kit allowed students to manipulate the tester and the electronic components while answering the task required. By doing the task, they were able to identify, measure, and analyze the electronic components as to their value, composition, and differences. The learning tasks were arranged logically, clearly, and concisely. So this is the example of screenshot of activity sheets. For the conclusion number 1, the microcontroller-based electronic components learning kit features easy setup, accuracy, user-friendly, and long battery life that will greatly assist teachers and students of electronics to achieve their learning goals in a more engaging and technology-driven way. Conclusion number 2, the acceptability of the microcontroller-based electronic components learning kit received very high rating from the respondents, implying that the product's design, durability, ease of use, and safety makes it an ideal instructional materials for high school electronics classes. For the recommendation for the teachers and instructors of electronic subjects are recommended to practice hands-on learning as a pedagogical approach and to reflect on more effective ways to use gadgets and other modern tools as instructional materials to promote optimum learning. And it is also recommended that electronic teachers develop additional activity sheets using the learning kit to cover more competencies from the EPAS curriculum. For the electronic enthusiasts and future researchers are recommended to develop a replacement battery of longer lifespan or even solar powered to allow usage to learning kit for more extended periods. And that's all. Thank you for listening to my presentation. God bless and thank you so much.